It's important to remember that the examples you are about to see represent best practice and aren't always reflected on client sites. This background knowledge may allow you to help a customer who is having problems with their system and spot dangerous situations. Let's have a look at how compressed air is generated. Here is a typical setup, although in reality the compressor is usually sited in its own compressor house to isolate the noise and heat. In some systems, there may also be a dryer fitted just after the compressor. The compressor will collect air from the local environment. It might be damp or dirty, caused by high humidity or passing cars, for example. The process of compression creates heat as air molecules collide more frequently. The air receiver is where the compressed air is stored. Think of it as a battery. It's where the energy is stored. The safety valve will release air if the pressure rises above the set pressure, for example, 10 bar. The pressure gauge displays the pressure inside the tank. It's advisable to locate the air receiver in the coolest place possible without dropping below freezing. Cool air holds less water and is denser. In the receiver, the water condenses and drops to the bottom of the tank, and so less air is stored in this space. The amount of water in the air will depend on many variables, including geography, seasons, and temperature. The condensate drain allows that water to drain away. It may be a legal requirement in your country to dispose of this correctly, as it could contain oil and other contaminants. The drain valve allows this drain to be switched on and off. The isolating valve allows the supply of air to be disconnected from the ring main. The distribution pipe allows all the energy stored in the air to circulate through the system.